Hi guys, so welcome back to the channel or welcome to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is day 66. We're going to continue our exploratory data analysis in Python from where we stopped on day 65. So we imported our data sets. We've actually started our analysis on it. So we're trying to explore the unemployment data sets. So we can see this is the first file we go to the data sets. We did some summary statistics to know whether they are missing or not missing values. We also did a couple of stuff like this summary statistics for numerical columns in the unemployment data set, where we got to find out the count, the mean, the standard deviation, the mean and max, the 25th, 50th, and 75th percentile, and the max power value. So we're just going to continue from where we stopped. So if you want to catch up on day 65, where we actually started this EDA in Python, which is Exploratory Data Analysis in Python, I'll just encourage you to go to the live stream tab on my YouTube channel, Excel Island, where you can catch up all the past lessons we've covered so far. So without any other delay, let's continue from where we stopped. Also, the data sets will be linked under the YouTube description, so you can always download them and also practice for yourself. This was the last lesson we did on that day. I just click on the dot it, and we can continue from here. So we're actually looking at data summarization in this instance. So we've covered getting to know a data set. So what is the best way to approach a new data set? Learn to validate and summarize categorical and numerical data, and create seaborne visualization to communicate your insight. So that was actually what we did in this couple of live streams, the past live streams. We created simple histogram on certain columns. We also changed the data types. We also defined a series describing whether each continent is outside. So we did a negative, we figure out the missing value in a particular column together. So also define a series of describing whether each continent is outside a certain continent based on certain column. We did quite a lot in the last live stream. I just encourage you to catch up by going to the live stream tab. Okay, so let's continue from here.
We ended the last video by exploring data by genre, noticing that children's books in our dataset have slightly later publishing years in general. We can explore the characteristics of subsets of data further with the help of the .groupBy function, which groups data by a given category, allowing the user to chain an aggregating function like .mean or .count to describe the data within each group. For example, we can group the books data by genre by passing the genre column name to the groupBy function. Then we chain an aggregating function, in this case .mean, to find the mean value of the numerical columns for each genre. The results show that children's books have a higher average rating than other genres. Other aggregating functions that are useful to chain with .groupBy are .sum, .count, .min, .max, .var, which returns the variance, and .std, which returns the standard deviation. The .ag function, short for aggregate, allows us to apply aggregating functions. By default, it aggregates data across all rows in a given column and is typically used when we want to apply more than one function. Here, we apply .ag to the books data frame and pass a list of aggregating functions to apply, .mean and .std. Our code returns a data frame of aggregated results, and .ag applies these functions only to numeric columns, the rating and year columns in the books data frame. We can even use a dictionary to specify which aggregation functions to apply to which columns. The keys in the dictionary are the columns to apply the aggregation, and each value is a list of the specific aggregating functions to apply to that column. By combining .ag and .groupBy, we can apply these new exploration skills to grouped data. Maybe we'd like to show the mean and standard deviation of rating for each book genre along with the median year. We can create named columns with our desired aggregations by using the .ag function and creating named tuples inside it. Each named tuple should include a column name followed by the aggregating function to apply to that column. The name of the tuple becomes the name of the resulting column. Now, we can get two summary values of interest about ratings, and our year data looks cleaner. We can see that the fiction genre has the lowest average rating, as well as the largest variation in ratings. We can display similar information visually using a bar plot. In Seaborn, bar plots will automatically calculate the mean of a quantitative variable like rating across grouped categorical data, such as the genre category we've been looking at. In Seaborn, bar plots also show a 95% confidence interval for the mean as a vertical line on the top of each bar. Here, we pass the genre column as the x values and the rating column as the y values. The results reinforce what we saw in the last slide. While fiction books have the lowest rating, their ratings also have a little more variation. All right, it's time to summarize the unemployment data in the exercises.
Let's use the knowledge we've learned so far in this last lesson. So the data set we're going to be using is this unemployment data set, which we have actually connected to from the previous lesson. We're just going to continue from here. I could just refresh the whole code and just run it. You could say see that. So the last thing we did, just to make it easy for me, I just open chapter 1 so I can always follow up on the lesson. So we're actually looking at data summarization in this type. Since instruction says in this exercise, you explore the means and standard deviations of the yearly unemployment data. First, you find means and standard deviation regardless of the continent to observe worldwide unemployment trends. Then you check the unemployment trend broken down by continents. So the unemployment data frame is available and pandas has been imported as PD. It says print the mean and standard deviation of the unemployment rate for 2019 and 2020 in that order. You just point to the data frame and you specify the column rather. And just take a little peep. So for the unemployment 2019 and 2020 column, I'll just go ahead and come here and so how do you do that? You can see you measure. So the question says print the mean and standard deviation. So you want to print, you can see the aggregation function there. Mean, sum, count, mean, mass, variance, and standard deviation. For the mean and standard deviation, we just do something like this. Just with dot arg, by the aggregate function, they introduce your brackets, then quotes, the square brackets rather. These are square brackets. They mention the two functions you want to use there, mean and standard deviation. In quotes, mean, comma, std. So that should work fine. Let's run the code and see. Oh, I'm having two quotes here. Supposed to be one. Let me just make sure I'm checking the code. Voila. So you can see, you have to be pretty careful here while writing your line of code. Let's copy this and make use of it in the system there. Let's see, we are going to get the same results. You can see for 2019, our mean is 7.2 and in 2020, 8.4. For the standard deviation, they are both similar. Let's check it as a 7.2, 8.4. So we are on track. Now, putting the mean and standard deviation in that order of the unemployment rates for 2019 and 2020, group by continent. So also group by a categorical variable now. Here you can see grouping by a categorical variable for columns. Let's take a look. Group by a certain variable, you can see. So when you introduce the group by, so print mean and standard deviation group by continent. So print the standard deviation of the unemployment rate group by continent. So we also want to look for the standard deviation of this year. These are the numerical variable group by this categorical variable. That is going to be thus group by. Must be dot group by dot group by. But this time around, I want to mention what wants to group by first, which is the continent. Also group by the continent. Continent. That is that. They want to look for the mean and standard deviation. So I need to add the mean and standard deviation there. I'm going to be dot mean. I'll just copy this line of code there. That's a pretty careful here. So let me just copy this line of code and see for now. Let's put it there. I like it to run into an error, which is normal. So let's get help on the error and see what's the mistake I'm doing there. So go by continents dot aggregation. I did add my ag dot ag. It is my aggregation. Then close brackets, open brackets. You have to close the brackets since I'm mentioning two different aggregation there. Voila. You can see. Let's look at this in this environment by standard book, for example, and see if we get same results. Voila. So you can see the mean and standard deviation for 2019 and 2020 for the continents, group by the continents. You can see there. That's kind of interesting. Let's submit and see. It's nicely done. So the data is well summarized, but it is a little long. What if you want them to focus on a summary for just 1 year and make it more readable? Give it a go in the next exercise. Let's see how to do that. Named aggregation. So you've seen how .group by and .arg can be combined to show summaries across categories. Just make sure I'm on live. Okay. Across categories, sometimes it is helpful to name new columns when aggregating so that it's clear in the code output what aggregations are being applied and where. Your task is to create a data frame called continent summary, which shows a row for each continent. The data frame column will contain the main unemployment rate for each continent in 2021. And of course, you will rename the columns so that their content are clear. The unemployment data frame is available and pandas has been imported as PD. Okay, let's see how to do this. Create the mean rate column. Let's see how to do that. Create a column called mean rate 2021. Let's create a column called mean rate 2021. Let's copy this. Mean rate 2021 is equal to choose the mean 2021 rates for each continent. Create a column called standard rate 2021. Okay, it's going to be for standard. Print continent summary. Continent summary is equal to unemployment dot group by dot ag. Oh, so these are continent summary. Okay. Mean rate 2021 equals to accelerate rate 2021. So your task is to create the correspondence which shows the rule for each continent. Okay, you want to focus on the year 2021 alone and the standard deviation for 2021 alone. Interesting. Oh, so this is column summaries. So it's going to be mean rate 2021. So I'm going to mention the year, then the aggregation. Oh, interesting. Let's see. The year is 2021 and the aggregation I want, which is mean. So I'm going to do the same thing for this scenario. We just copy this. So it's normal to run into an error. This is going to be STD, standard deviation. Let's run the code and voila, we nailed it. You can see the mean rate 2021, which is for the year 2021, and the standard deviation for 2021. So let's see it in action in my Jupyter notebook here. If I run the line of code, voila, we have the same thing. So we look at, we name the column specifically, and separate the mean rate column, and declare the standard deviation column, which is the unemployment of group by continent dot ag, which is a cool way to actually have a good summary. Let's make and see. Super amazing. Average total unemployment varied widely by continent, and so did the unemployment with those continents. Oh, interesting. So, never mind. I've just been busy a couple of days. So let's continue. Let's visualize our result. This is the last step here, visualizing categorical summaries. As you've learned in this chapter, Seaborn has many great visualization for exploration, including a bar plot for displaying an aggregated average value by category of data. In Seaborn, Bar plots include a vertical bar indicating the 95% confidence interval for the categorical mean. Since confidence intervals are calculated using both the number of values and the variability of those values, they give a helpful indication of how much data can be relied upon. Your task is to create a bar plot to visualize the means and confidence intervals of unemployment rates across the different continents. So unemployment is available and the following has been imported for you. So create a bar plot of continents and their average unemployment rating. Interestingly, this is similar to what was done in this last part here. A bar plot of the continent and their what? And their average unemployment rating. So that is going to be SNS the bar plots. So let's see. This is gonna be it's going to be tricky. Say the average 2021 unemployment rates on the y-axis. Average. So we want to do that is the mean unemployment rating on the y-axis. On a usual ground, the data could just be our data set is unemployment. Our data set is unemployment. And our x-axis is continents. And our y-axis axis is 2021, but it says the average. So to make it of the average, can we do the average of that in this instance? Let's say dot me. That's going to be tricky. But that wasn't actually done here. Let's see pause. Okay. Is it continent or continents? Okay. Hopefully that is correct. For the distance that we have, the mistake that we say we have is that we don't know if this average internal unemployment rate on the y-axis is the correct uh, column. Let's submit and see if that is correct. Oh, that's absolutely correct. A perfect plot. Way to go. While Europe has higher average unemployment than Asia, it also has a smaller confidence interval for that average. So the average value is more reliable. And when we look at our data set from here, the value that we have here are the average probabilities are the average for each continent. So if we are not sure, let me just give it a shot here. If you're going to have the same results. Voila, you can see we have the same results here. Average unemployment for the year 2021. Interesting. All right. I think this is the end of chapter 1. So we've actually completed chapter 1. We are moving to the next chapter, which is addressing data cleaning and imputation, addressing missing data, dealing with missing data, strategies for remaining missing data. And that will be what we are going to tackle next on the 66 of the live stream. And that will be the end of the live stream for today. I hope you find value in this learning journey of Python with me. Do want to support the channel by giving the video a thumbs up, that subscribe button, and I'll see you on the next live stream on day 67 as we continue to chapter 2 of this learning journey. So we'll be skillful in Python. Bye for now. Have a wonderful rest of the day.